Oh, hello everyone. My name is Russ Grease. Today I'm going to talk to you more about my video I posted last week about Stan Meyers' self-running generator. I have gained a little bit of information. This is just what I could afford to print off, so I'm going to go through some of this stuff with you and share the information that I've learned. And then I'm going to show you some videos of Stan talking about this whole entire contraption, and he explains it very well. And I'm going to pause the video and put my own words into the video and let you guys think. Again, thank you. I just want to say thank you for everybody's response. Overwhelming. You guys sent me messages and information and left me comments. I read them all, looked through them all, looked at everything. So thank you very much. Keep that going. Again, I'm going to put all the videos and the links and my personal video, this one, in the description. And what I want you to do is download it and upload it and mass email all the information within the description of this video. I need you to do that so that you can get people to think about this stuff on the same level and work on this together. It's all about us. It's about me and everyone out in the world learning this technology on the fly so that you all have the same capabilities I do, and we can actually build something, because I need help with this. I'm alone here right now. With you all I'm not, so I need your help. That's the whole purpose of putting this on the internet. I'm not smart enough to do it by myself. I need your input and feedback. It's just the way life is. Alright, I'm going to quit talking and get started. Now, the first thing that I've learned, and this is kind of silly. Last time I talked about the patent right here, and it's called the electrical particle generator. There's the patent number. It's a Canadian patent number. It's 1213671. I'll post all these patents and everything. I'm going to put a huge file and on the description so you can download everything that I have and I'm going through. Now, that's the first patent, and it describes the generator. It's real, and basically it just tells what it is. And as well, it also had this diagram in it, which we didn't know if was water in here or no water or what. I think I figured out what this is, and I think I figured out how to make it work. And again, I need your input. Alright, so this is what I'm going to tell you. I looked for patents, and I looked and I found a lot. There are 4 patents, okay, for the same thing. One is Canadian, one is American, one is European, I'm pretty sure, yeah, European, and the other one is Chinese or Japanese, one of the two. So I cannot read that one, obviously, but I read all the other ones and I went through them, and I'm trying to find the differences between them, because there are differences between them. For instance, check this out. I showed you this last time. Okay, and this is some stuff I'm observing, and I need you to observe it with me. This little box is where the magnetized particles come into the hydrogen and oxygen being created from the water in between 2 plates or more. Okay. Now here's the problem I have with this picture. Take a good look. Alright. Now look in the earlier patents. That's the U.S. patent, number 4613304. Now if I jump back to the Canadian patent, there's a problem. I'll show you what the problem is. No particle box. Okay, so between, I believe this was 1982 and 1986, between those 2 patents, he added this particle box. Okay, so that's an observation, as well as the other patent from Europe. It has the same diagram as the Canadian patent, with no particle box. Now here's something interesting. Keep my finger on all these pages. Alright, here's the U.S. patent. Alright, and basically, right here, there's nothing in that diagram. Now look at the Canadian Europe patent. You see that? North and south. It's actually got north and south magnets. It shows you that's where you polarize the particles. Alright, where here, It doesn't tell you anything. It just says polarized particles come from that. Okay, which means the magnetic field is here, and whatever this is, which I believe is got to be that first picture in his very first patent about this device. Now, the device has multiple names, and the true name for it is the EPG, the electrical particle generator. That's what he refers to it in all his videos that I've found. Okay, so that little box that I showed you's got to be this. And these two magnets, this box here is a magnet, okay? Patent number for that one's a Canadian one. Alright, so that's the information I found. Now I've also found something about the tubing. Last time I was like, what is the tubing? Copper? Is it not copper? You know, what's it made out of? Plastic? Rubber? We didn't know. But here's something quite interesting. Bear with me on this first part of this video. It gets better, I promise. I just got to hit the basics real quick. Alright, this is going to be hard to see, but I have two patents. This is the European, this is the American. The American says, right there, you see it in circle? Non-magnetic, non-conductive tubing. Now this is the older this is the new version, and it's got the particles coming into it, already polarized. Alright, here is the European one. It just says non-magnetic conductive loop of tubing. Okay? So, I don't know what to think about that. One says non-magnetic conductive. The other says non-magnetic non-conductive. And the prior one, where he just talks about the generator itself, it just says non-magnetic conductive. Oh, that's the wrong one. No, it just says non-magnetic. The other one also says non-conductive. So I got conductive on one and non-conductive on the other. How do I take that? The only thing I can think of is that the older patent from 1986, is basically figured out a better way to do it. Now I want to show you a picture of this. Before I do that, also in these other patents that was not in the American one, it talks about this in random spots. It says right here, gas line tubing for maintaining a polarized hydrogen-oxygen atom circulating through the said non-magnetic tubing. So I have a problem with that because it says it in different places that basically this loop of tubing here, if you read through these patents, and I'm going to make you read through them this time. I don't want to spend that much time on this. I want to get to the points that I need to let you know about. Basically it says from this point, alright, this is all non-magnetic conductive tubing, and then from this point to this burner is basically, it says gas line tubing, which I would think would be rubber. And then it goes down here, gas line tubing and gas line tubing. Now there's multiple instances where it says the the non-magnetic tubing comes all the way through and all the way back to the said chamber. Okay, and sometimes it doesn't say that. Sometimes it says it stops here and it's rubber. So I don't know what to tell you, but I have a picture here I want to show you. I may go through this a little bit more real quick, but I have a picture I want to show you that you can see it is copper pipe. You can see the whole apparatus is copper pipe. I'm going to go through a little bit more and then I'm going to show you because I got stuff I want to try to explain with you of this picture. I don't remember the person who sent me this picture, but he found it on a forum somewhere, and it's a brilliant picture. It's just unbelievable. So, one second. Okay, guys. So I'm going to talk about the earlier patents, and the earlier patents in one of them. This is the Canadian one. This other Canadian patent I'm talking about is 1228833. Alright, and it is the gas electrical hydrogen generator. Here's what it states. It says, objects. It is a principal object of the present invention to provide a hydrogen gas electrical generator capable of producing a voltage/current much greater in magnitude into 4 possible. Another objective of the present invention is to provide such a hydrogen gas electrical generator utilizing magnetized elements, and wherein the magnetized elements are charged gas particles from a hydrogen generator. It does not say anything about magnetized particles from another location. It doesn't say anything like that, and that is the one with no chamber beside it. Okay, where the older patent has one. So obviously, Stan found something out, and in the older patent it says that the magnetized particles, okay, permanently magnetized particles, superimpose themselves onto the hydrogen and oxygen. Okay, so basically, it will work with just hydrogen and oxygen, and you can magnetize it, but it doesn't say permanently. All right. Alright, it also says here in the older patent, Canadian patent, and I think it says it in the European one as well. There is interposed in the line 25 a magnetic polarizer having magnetic poles, and the magnetic polarizer may be a permanent magnet or an electrical magnet capable of creating a magnetic field across the non-magnetic tubing. The magnetic field, in turn, imparts a magnetic charge to the gases released from the storage chamber. The hydrogen gas particles become positively magnetically charged, and the oxygen particles become negatively magnetically charged, producing a magnetized gas mixture. Alright, so he is using hydrogen and oxygen alone, and he even states that the hydrogen is positively charged and the oxygen is negatively charged. Okay, which means they align in a certain way. So that's very important information right there. Alright, it also talks about the pressure, and it basically says the volume of the hydrogen/oxygen gas is directed by the storage area, and the pressure of the hydrogen-oxygen gas is stored therein determines the magnetic field strength. It says the greater the pressure, the greater the velocity, and in turn, the greater the voltage/current output. So the more pressure and the faster it's moving, the more output you get. So basically, the more atoms you can cram in there, and the faster you can shoot it through that tube, the more output you get. Now, if you compress hydrogen and oxygen alone, they will explode by themselves. You do not even need a spark. So be very careful if you play around with this stuff. Now, yeah, I'll tell you more in a minute. Now, talking about, right, it states later in the patent, it says to increase the gas pressure in chamber 23, other non-combustible gases, such as nitrogen, are added via pressure inlet means to the mixture. So basically, if you get too much hydrogen and oxygen in there, you can put in a non-combustible gas and pressurize it even higher. To get that mixture right, I don't know, that's something we need to talk about. Alright, real quick, I want to show you something on this is the older patent, but also the newer patent. This pipe coming back into the chamber is got a check valve on it. Only allows things to come into the chamber, and that's it. There's also another valve for inputting non-combustible gases, such as nitrogen. That way you can compress this chamber. I kind of drew in a little valve right there. It's hard to see, but that's what it looks like. Alright, one more thing I want to talk to you about real quick, about pieces and parts of this device. Stan's idea behind this whole entire project was that he's got to be able to build this in his garage. And even in his patents, it says here, a further objective of the present invention is to provide such an electrical generator that utilizes components readily available and are adaptable to simplified embodiment. So basically, what that means is readily available parts. So the electrodes we were talking about in the other video are probably a very common material. Now, I have some really good thoughts on this, but I'm going to share those a little bit later in the video. Okay, guys, that's about it for the patents. I really don't want to go through the patents too much. It just takes up so much time. You guys can read it on your own. But the patent numbers that I'm dealing with, again, Canadian patent 1213671. That is electrical particle generator. That's like the first patent. The second patent is gas electrical hydrogen generator. It's Canadian patent 1228833. The next patent is a European patent, and it is again a gas electrical hydrogen generator. It is European patent 0106917. And the last one is the U.S. patent. And I already gave you that one a while back, but it's 4613304. All that information is in the description, so go look at it. It's right below the video for now anyway. Things always change. Now here's what I want to do. There's been a lot of people's feedback. This is great information. And so what I'm going to do is show you a video. Alright, I'm just going to let you watch this video. I might pause it here and there and talk about what he's trying to say or my ideas on this. Alright, so right now what I've got is Stanley Meyers videos is the guy's username, and it's the New Zealand interview, part 8, at right about 11.5 minutes or so. Alright, here we go, guys. You ready? I'm gonna just pause this here and there, and I'm gonna explain a few things or try to, or give my input on this. Okay, this is gonna be about a half an hour, I believe, something like that. So here we go.
Restrict the amp level and voltage to take over, but we need to produce a lot of electrical power. Now, most of the electrical power plants are being propelled by coal or gas or what have you. We can use the water to do this, but there's cases now where we need higher energy yields, and so the EPG system was developed for this purpose.
He said the EPG system, electrical particle generator. That's what that stands for.
One is, that I was showing you, with the magnetized gas inside the closed loop tube. We're using various methods to propel the gas.
Alright, so he said the same thing as the patent does. Non-magnetic closed loop tube.
Now, in this particular case, we were talking about...
By the way, this video is, I believe, around 19... I don't want to get it wrong. I'll look it up later and put it in the description.
The electric motor driving the non-magnetic turbine wheel, which could be converted to wind power and what have you. If I wanted more power output of this generator, what would I do? Could I put another pickup coil here? Yep. And could I put another pickup coil here? So power output of the generator is determined by what?
The amount of coils.
Right, it's determined by, number one, the strength of the magnetic field, the velocity of that magnetic field, the number of turns per coil, and the number of coils.
Alright, that's what I was saying about the gas. He's talking about more magnetic, as in probably more pressure, and obviously the velocity.
Right? So all of these not comply with the power factor of electrical power generation. The only thing I've done now is I have eliminated the opposing magnetic field problem, which was the greatest problem in electrical power generation. Now I'm a little tired of the non-magnetic tube, and so in some cases I now have put in an electromagnetic pump. And I come over here with an electronic pulser, and I now want to produce an electrical generator that has no mechanical moving parts.
Now he said, I'm tired of the non-magnetic tube. Now that's another thing I need to show you real quick. I'll zoom out here. In those patents, there are cores over the primary winding. Okay, so here's a picture. Okay, here's the primary winding. These dotted lines or these slashed lines, that's an iron, some sort of an iron or steel core. Okay, so the coil, the primary is wrapped on a steel core. That's important to know when you build this. I'm going to try air cores, but I'm also going to do it this way because all the patents show that, and he even explains it. Alright, keep going.
Now in this analysis, if my eraser was a magnet, and I would put the magnet close to the magnetic gas, would it lock onto the gas? Yes.
Yeah.
All right, now, so if I move the permanent magnet, would I now move the gas?
Yeah.
So therefore, if I now take this coil and I energize this coil to produce an electromagnetic field, then I deflect this magnetic field in a vertical direction, would I not now move the gas?
Okay, Now that's another point in view. I'm going to pause this video and I'm going to show you a picture. This picture is of a device that is Stan Meyers from what I can tell. Okay, this is a pretty interesting photo. And you can see here in the middle, right here, there's coils. Okay, and they are lined up. They're not just one big magnet, or coil I should say, electromagnet, but they're just not like that. Another picture here. Okay, there's your coils again. You see them? 1, 2, 3, 4, 5. Now this one's a little different, but you can see how the coils are. Now in another video, I found this. Okay? So get this. Multiple coils, and it goes into a box. Unfortunately, you can't read any of this, and you can't read it in the video either. But if you pulse one, and you pulse the next one, next one, next one, next one, and next one, you're gonna shoot. You're gonna create a, basically, if you think of it as the way a roller coaster works that has electromagnets, when they shoot that sucker off, you start here and you fire them in a sequence. All right, and they're firing in a sequence. So that, I believe, is very important, is to fire these in a sequence. Otherwise, these would just be all tied together. All right, so I think that's an important thing to remember, because he always shows that. Let's keep going.
Where's the bearing? Where's the contact brushes? Can I now either hook this up?
Well, off to the next one. All right, that's 8. That's the ending of 8. Now we got to watch 9.
Series or parallel arrangement, come up with any power output I so desire?
Yeah, what about the geometry of that system? Can you not refine that so that you were describing this in terms of a square?
Oh yeah, sure.
Yeah, but that's not the geometry of it in real terms.
No.
Okay, he's talking about the geometry. He always draws it as a square. Well, there's what they look like. They're not square, obviously.
Geometry in real terms, it is now going circular in spiral configuration. What were we talking about that last night?
Acceleration, right.
Yeah. Now, the key to it is, for example, if I had the electromagnetic pump here, and I now had the magnetic tube like this going around.
It becomes a coil.
All right, now it becomes a coil. Now, if let's take an analysis of this. Let's say that.
Right there in that part, he says this becomes a coil. I believe that is very, very significant, because if this becomes a coil, and actually I just kind of thought about how this worked, if this whole loop here becomes a solid coil, the way the magnetic flux lines flows is going to be interesting. So a little bit later he talks about this being copper, and as you can see in this photograph, if I zoom down here to the bottom, right here you can see this is a copper line, and you can see between here, these are copper lines. Alright, now it's, I believe copper is what, paramagnetic? Ferromagnetic? I don't know my magnetics very well, but basically it's conductive. But in that last patent, it says it's not conductive. So that's very, very something to remember. And if you look at the scale of this device right here, if it didn't work with copper, why would you build one this big? Okay, something to think about. So the copper is actually, I believe, part of the circuit as far as how this thing functions properly. So it's just something to think about that we all need to discuss and figure out together.
Coming into this, this had a given magnetic field strength. Now, in electronics, if I were to take a coil and I wrap this coil many turns, the more times I wrap it, the stronger the magnetic field would become, right? So if I had 1x magnetic field here, and I coiled this now, and let's say I coiled this 100 times, what's the magnetic field strength of this?
It becomes exponential.
All right, so therefore it's 100 times. All right? So I now start to wrap the coils around this circular pathway, this coil pathway, as you see here.
Coil on a coil.
Coil on a coil. Now my power output is determined by, again, the strength of the magnetic field, right? The velocity of the field. And what's my next equation? The number of wraps, right, of the coil, and the number of turns per coil.
It gives you field strength.
It gives me tremendous field strength. Okay, so here I'm using now an electromagnetic pump to produce the electrical energy.
Now, Larry, draw lines between there. That is a sign of sequential firing of these coils, in my opinion. Let me know what you guys think.
Now, when you get to EMF fields, there's a reason why this was developed this way, is because the next question is, I want to eliminate as much as possible Lenz's laws. On opposite Lenz's laws, okay? So the prior state of the art says here I have a coil, and I'm now moving the magnetic field through this coil, and I'm now moving it perpendicular to the coil. So I have tremendous opposition in moving that magnetic field, as he was pointing out, right? Well, now, can I move a magnetic field inside another magnetic field?
Yes.
And could I do it in a way that minimizes the amount of opposition?
Coherent.
Absolutely.
Coherent.
Okay, so Larry's talking about moving a magnetic field inside of a magnetic field. Now, this is where I just started pondering these ideas. But basically, here's what you got. Okay, and if you were moving a magnetic field this way, inside of those other coils, in that copper is part of the circuit, then there's going to be some interesting results there. So I have this bad feeling that the copper needs to be there, even though the last patent says non-copper. So again, I really need some info on that one. That's something very interesting. I know there's interesting things when you use electricity with copper, but magnetics with copper, the only thing I can think of is when you drop a magnet down a copper pipe, you create eddy currents, okay, and those eddy currents go through that copper pipe, and they show on the outside as well. And so if you're moving magnetic gas and you have these eddy currents flowing within this copper pipe, the output is actually probably part of the eddy currents in this system. Very, very interesting design, and again, I'm afraid the copper is going to have to be there for this device to function properly.
Yeah, because under this analysis, the magnetic fields are moving perpendicular, so you have opposition. But if I moved it through this way, I have a minimum amount of opposition to the movement of the field, right? So when you develop an EMF field of a coil, which way does the EMF develop?
At right angles to it.
Yeah, it develops away from the coil. That's the EMF.
So you take it with the coil.
Yeah, so now you got a situation that,
Well, you change the whole load of the electrons.
well, but, am I defining laws of physics?
Doing not a cosmos.
Yeah, okay. So here is the magnetic field of the gas. That's the gas, right? And this is the EMF field. So therefore, can I not pass this magnetic field through this magnetic field and have minimum amount of opposition? Right? So when they say they cannot do it, it's the way you should look at the technology.
So we've developed technology that's produced that effect, but that
Yes.
effect need not necessarily be like that as you prove.
Yes. So therefore, I have eliminated or reduced Lenz's law down to minimum, because I'm moving this magnetic field inside another magnetic field, which gives me the least amount of opposition.
You're still getting the same pickup on the coils, though.
Sure. Absolutely. So
The axis is a 0 point.
Right.
Theoretical.
the center of anything is negligible force.
Right.
There's a negligible force in the center.
Theoretical axis.
Right. So the differential is from 0 on out. And so therefore we have the ability to move the magnetized gas with very little opposition to it. Now you link this up with a water fuel cell, and the water fuel cell now is producing the electrical energy. Can I not increase that electrical output still further? All right, now when you move the magnetic field through that alternator, that field moves at a very slow pace, very slow. So now can we increase the speed of the magnetic field? And can we not do it in a way that we can increase power output still further? So we've taken the technology now, even to a very higher state. We have now taken it to a point of solving the problem of over-unity devices.
Solving the problem of over-unity devices. Okay? Just something to think about. Now what he's drawing now, he's going to be using laser energy. Now when he says laser, I'm 99% sure he was talking about LEDs, because in all his patents he has drawn in there like either UV or red or ultraviolet LEDs. I could be wrong. Something to think about.
By simply now injecting laser energy input into the magnetized gas. Now what I want to do is give an analysis here. Now let's say, for an example, this is exit. All right, now I want to increase power output still further. And I'm now starting to inject laser energy into the magnetized gas. Now the key was, how can we increase the magnetic field of mass, or increase the magnetic field without increasing mass? Now if you're doing that, you can do something. Now we talked about the coil wrapping, but another classic example is if I had the magnetized gas here, it's a phenomenal effect that if I would inject laser into the process, this electron would move out to a higher orbit, would it not?
Yeah.
Now in the law of physics, I better stop. In a mechanical drive system like
Larry says I better stop and the camera quits. I'm not sure if he didn't want to say something, film, if he didn't want to say something on film, or if they had a problem, or what the deal was there. So that kind of interested me. Keep going here.
It's an electromagnetic pump system to drive the magnetized gas. I pointed out in the development of the electromagnetic pump system that will drive the magnetic gas, and all of its physical parameters of producing electrical energy very economically. Now, the question now comes, can we produce large amounts of electrical energy by moving the magnetic field even or close to that at the speed of light? Because the magnetic field movement through a rotary electrical generator is relatively very slow. Now, the key to higher power generations was in the areas that, like on over unity devices, as we have mentioned, is that the power limitation was that to increase the permanent magnetic field, you had to increase mass, which meant you had to increase the energy input in to move the mass, so that inherently became a detriment to trying to produce electrical energy. So can we not now, for example, go ahead and then amplify the electromagnetic field of the mass without increasing the mass? And what we found out was that as you inject laser energy, and the nucleus is absorbed in the magnetized gas nucleus, then this electron now will move out to a higher orbital state. And we know that under the law of physics that when you do this, something's got to happen, right? And yes. In one.
That guy made a comment. He talked about anti-gravity. And if you think about it, if you really did get particles accelerating that fast inside of a closed-loop tube at the speed of light, can you imagine what kind of effects you'd have on the system like that? So that's just something else that's very interesting to think about. Anti-gravity. He made a comment, and Stan says yes, he agrees to that comment. So that's very interesting.
One thing that takes place is that this electron, the electromagnetic field now, that holds it in its outer orbit becomes weak. And when this becomes weak, then for every action there's an equal and opposite reaction. Then this electron starts to spin at a faster velocity. And under the electromagnetic theory of magnetism says that whenever a negative charged particle moves through an electric static field, B, its byproduct is electromagnetic energy. You know, there's 4 forces that affects the atoms. There's electrical force, electromagnetic, weak and strong nuclear forces. It's the electrical force that really is applied to difference of potentials that applies directly to the atomic structure of the atom, and then all the elements are just built on top of that. So in reference to increasing the magnetic field strength, it was quite obvious that all we had to do was eject and allow laser energy to be absorbed by the atoms of the gas to now cause the electron to spin at a faster rate as it's now moving away from the nucleus. This gave us the ability to increase the magnetic field without increasing the mass. And that was the answer to over unity devices. Now, we're producing now, as we eject the laser energy into the EPG system, I've now converted the non-magnetic tube into a light guide. Light guide.
Now he talks about a light guide. Now, if you made this out of copper, theoretically, the light would reflect pretty well off the inside of a copper pipe. It's pretty shiny. So they may have not even had to coat it. But then you got to remember, if it is all copper, you got to think about erosion and how this type of atmosphere inside this tube will erode at this copper pipe. Something else to think about.
Now what that means is that I've now put in a reflective surface inside the non-magnetic tube. So now when I inject laser energy, a bolt of laser energy into this system, and let's say for example this is a 10-watt laser, I'm now producing this magnetic field strength.
10-watt laser. He says the same thing in another video I found. A 10-watt laser. How many LEDs would you have to have a 10-watt amount?
A. Now, as I do this, then this laser energy would not now start moving through this corridor, reflective corridor that close around the speed of light. So as a result of this, now this laser energy is starting to move this field, this pulse field, and it starts moving and bouncing back and forth and closes this loop system and produces it at an extremely fast rate close to the speed of light. So if I want to increase more power output, in one example, as we pointed out in the prior art, I could add more coils to it, right? But now I want to increase tremendous amount of power. Let's say, for example, that I would take this non-magnetic tube, and
Non-magnetic tube again.
I would take it from here to Auckland. How far away is that?
20 miles.
20 miles. And then I take the tube and loop it back here. And I wrap 1,000 turns per coil around this non-magnetic light guide. And I hook these coils in series parallel arrangement all the way to Auckland and back here. And I fill it up with a magnetized gas, and then at the one end I set a laser to it. Now if I take a laser and I strike the laser, how fast would the light energy go through the tube to back to here?
Speed of light.
And then faster you can blink your eyes, right? Less than a nanosecond, right? Alright, so now if I take a 10-watt laser and I laser and I produce this magnetic field strength, it would now move close to the speed of light to come back to here. Now, when I get back to this point right here, I now laser it again. And I strike the laser again, and now I have an intensity of the field equivalent to B psi. And that now compounds itself and bounces around and gets back here again. I laser it the third time, and I produce a magnetic field 3 times in its intensity. Now imagine taking that laser, and I strike the laser 1,000 times, or let's say 1,000 times in a 10-watt laser. What would this magnetic field strength be equivalent to?
1,000 tons.
Yeah, so it'd be 1,000 times greater than, 1,000 times the 10-watt laser. Okay, so I have what, a 10,000 or 100,000 watt laser equivalent of moving this gigantic magnetic field. So I'm now moving this magnetic field close to the speed of light. Now, the EMF field of the coil is only generated after the magnetic field goes through the coil wire, right? So as that bolt of laser energy is going through the gas, then there's very little resistance of this being moved through the coil, because as it's going down that coil, it sees an open corridor with very low resistance. Is that not so? So the EMF is only built afterwards. So if I would pulse this now and set this field and pulse it and hit it at this intensity, how much electrical energy do you think I can generate?
More than you ever want.
I can generate all electrical energy for all the major cities.
So in other words, you've done
in New Zealand.
the song bar, you go from the EMF bar.
Yeah, sure.
Are you saying that the laser will carry the gas around with it?
No. The gas remains stationary, and the laser action, in other words, the atoms
expands and contracts.
right. And so, isn't that nice?
Okay, so he just said that the laser doesn't move it. The gas is stationary, and the electromagnetic pump moves it, or just stays stationary, I assume. And basically, he's taking the electron and making the electron's orbit out further. So that's just a whole interesting theory, which I do not know if he actually added to his system, because on the systems that I've seen and the stuff I can see, I don't see a place for input of energy like that. The only thing I can say is that there's something in the bottom of this here, and I do not know what it is, and I cannot tell what it is. Let me show you a better picture that I have. Here's a picture of the this file is called the Water Fuel Cell Newsletter number 3. It's in the documents I'll be posting. You can see it. Well, maybe you can see it a little bit better. Basically, this looks like 1, 2, 3, 4, 5 IC chips and another chip here. Looks like a 555 timer of some sort. Now you see a coil here and you see a coil here. I personally believe the incoming coil is going to be the one that polarizes the gas, maybe, and the other one is the one that's making the gas turn or go. Well, I guess this has got the electrical pump, so maybe they're both input coils. I don't know. Something else to think about. Alright, let's keep going.
Streamline would be just like a hypersonic aircraft. It's leaving the shock waves behind it.
Right.
Go ahead of the shock waves.
Right.
Absolutely no.
Isn't that amazing?
Now, he just talked about a jet line, or a jet, and leaving the basically breaking the sound barrier, where the EMF field is behind the light field that's going through it. So you're almost creating a supersonic boom situation, but with light and particles and magnetics and EMF fields. So just some interesting thoughts in this video, that's for sure.
Now you link this electrical power generator with the water fuel cell technology. What can you not do? The technology is only limited to the imagination for you to put it to work.
That on its own, just as is just phenomenal.
Yes, but you can't run the entire economy off of this power, because as I pointed out earlier, an electric motor cannot handle the workload of an internal combustion engine. And under the law of economics, we don't have time, for example, to change to electrical drive systems for cars. Detroit, for example, is not going to change their production line when Stan Meyers shows them how to take a $2.50 recycling tube, use the exhaust gases to adjust the burn rate of hydrogen gas to co-equal that of the fossil fuels, and run it off of water. So the law of economics dictates that this is the direction we'll go. But the evolution of its development will continue this because, as I was mentioning to several others during our break, that the main centralized power systems have turned out to be the wrong approach in order to provide power, like in the United States, because in the interim period of time from the time the first power plant was developed, a lot of the copper wires or the electrical transmission lines are starting to crystallize. So we're starting to have breakdowns, the Brown effect occurring, or the electrical wires are now breaking down because of the high exposure of voltage, and they're crystallizing, and we don't have the copper to go ahead and replace those transmission lines, nor do we have the monies to be able to restring the transmission lines. So one of the main philosophies now in the United States is to come up with a home power generation system. So we link this to a water fuel cell, and we're going to be releasing this unit, which will be the equivalent to the half size of a hot water tank, about 18 inches in diameter.
Okay guys, a half size of a hot water heater. Now, this video, you can actually see, not video, but document here, this is the newsletter number 3. You can actually see about how big it is by, by him standing next to it. Okay, so you can get a size of this device. And this is in that picture. You can see the transformer, that's right here. The little power strip with the switches and stuff in it, and the pump and the 2 coils. Just to show you another picture of that particular one. This is off of a video. You can see that that is the exact same one. Here's another angle. Now, it's hard to see, but the circuit board that used to be down here is gone. Okay? See the circuit board right here? Right here, it's gone in this other picture. This is the Stan Meyer State videos I captured these off of. Yeah, I'll talk more about this later.
And its average power draw will be 220, 300 amp draw capacity.
He just said 230, 220, something like that, amp draw capacity. Now, he didn't give you the voltage, so you don't really know the wattage. The voltage could be extremely high. We don't really know. Let's keep going here.
And link this up to the water fuel cell, then we have an unlimited power source, very economic. And the only thing I'm using here is a tube, a bunch of wires, in the gas. Now, we're not pointing out how to make the magnetized gas for an extremely long period of time, because when a scientist comes into my laboratory and says, if you can show me how to stabilize the magnetized gas at room temperatures, you're doing something. And
if you can stabilize the magnetized gas at room temperature, you're doing something. Basically what that means is you're creating a superconductor, but fluid, but one that allows magnetics to go through it. So this whole idea is just so interesting that I'd like you guys' help to work on this project.
He's right, because this will set on an evolution like you will not believe. Now in chemistry, in linking up with atoms, we're always under a natural state in order to link up the atoms to covalent link up. Now there are a lot of ways of doing it. Now there's 3 atoms that exist in nature that exhibits electromagnetic fields. There are iron ions, and there are nickel ions, and there are cobalt ions.
Okay, now when I was doing my research, pause that for a minute. When I was doing my research, basically, I found nickel, iron, and cobalt. And I found those in these enelco, can't pronounce that right, magnets. The ones that are really shiny, real hard. Alright, I was actually thinking about using these as my electrodes, because the only thing they have extra in them is aluminum, and something else is in there. But again, in this patent, the very first one that he patents, I believe it's the first patent, has this device. We don't know what this device really is, except vaporized particles come off here and get permanently magnetized here. It's all we know, pretty much. These are electrodes and an electric spark here. So if these were the electrodes, and I made them out of this material, I'd get cobalt, nickel, and iron, or I could just do one of each. Alright, and you have a plasma arc here, or a spark gap, high voltage spark gap. Now the thing you need to remember about that is when you have a plasma here, you ionize the air around it and whatnot, if I'm not mistaken. And I could use some help here, so if I'm wrong, let me know. But you ionize some of this stuff. Now, he talks about argon being the gas. I personally think this is a drawing of the first stages of this development in this device. And later he uses other compounds, such as hydrogen, nitrogen, oxygen, and maybe something else even, because he's got the particles coming in and superimposing on the hydrogen and oxygen. So there's just a lot going on here that we all need to discuss. I do not have a forum set up for this, but if somebody wants to do it, go for it. Unfortunately, my time's so limited. Comments and personal messages is the best way to get a hold of me, and my email. All right, let's keep going.
And the key to the link up was to come up with a gas lattice that would stabilize at room temperature and amplify the electromagnetic field. So one of the techniques, this is not the only technique, but this is the technique that I'll relate.
Okay, and he said this is the technique that I will relate, as in prior state of doing hydrogen and oxygen, he was using this. All right, and I believe that's exactly what this is. Forgot to mention that if this chamber was filled or vacuumed and then put argon in here, with this spark gap, you would ionize the argon as well as vaporize the material the electrodes are made out of, and those should, because the electrons are stripped off of the argon, ionized, I'll probably say that wrong, but ionized argon, then you have a more probable chance of those connecting in the proper structure, which is what Stan's explaining right now.
But there will be an evolution now in chemistry where hundreds of millions of new chemical compounds will come about as a result of this. Under the prior state of the art, there are such atoms now in this particular case to make a magnetic gas lattice.
A magnetic gas lattice. That's kind of something important to know about. A gas lattice, as in a structure.
We're going to use an iron and iron ions and argon as an example.
Okay, iron ions, which is vaporized iron, in my opinion, and they are stripped of some of their electrons so that they adhere to the argon. That's what I'm getting out of this. Someone with much more experience should let me know, and let me know if I'm wrong. That'd be great.
Iron, cobalt, and nickel are atoms. Now, they look at it as a metal substance, but really they're composed of the same atomic structure. They only have different number of protons and different number of electrons, right?
So he's talking about, they're solids, but if you vaporize them, they're now an atomic state. That's what I'm trying to do with the electrodes in that first patent.
All right, so if you get them down into the atomic structure, then they operate and function just like any other atoms do. And now, the reason why iron, as an example, or cobalt or nickel exhibits electromagnetic fields is because all their electrons rotate in the same direction. The reason why the wood and so forth does not exhibit an electromagnetic field is because their electrons pair together and they rotate in opposite directions. Okay? Has been examples of taking atoms and exposing on a plasma under real high temperatures and high pressures, and they would start to exhibit an electromagnetic field. But tremendous energy must go into that type of system to try to generate the magnetic field. So the key is, how do you stabilize it? Well, as we pointed out earlier, that when I took the combustible gas atoms, which we call the hydrogen gas gun, and we...
Okay, he talks about the hydrogen gas gun. Now, there's another video, and I'll put that link in the description. He talks about the hydrogen gas gun. So that means that the technology was like already comprised before they did this, but after the first patent, in my opinion. Keep going.
Expose that atom to a high voltage field, we got the ionization effect occur, right? Now, in this particular case, I'm using iron and argon atoms to link up. Now, traditionally, argon is an atom that doesn't link up to anything. It's chemically inert. Why is it chemically inert? And the reason why it's chemically inert is because its second electron orbit is composed of 8 electrons. Right, and as it has its 8 complete electrons, it doesn't want to covalently link up to anything. Well, now, the question is how do you look at it to accomplish the problem? Well, if that has 8 electrons, why can I not now expose the argon atom to high voltage and pluck off its electrons? Can I not do that?
Now, he talks about exposing the argon to a high voltage potential and plucking off electrons. Alright, in my opinion, that's what this would do. You have a high voltage potential here, and you have a plasma arc here, which in turn would do that if I filled this chamber with argon. So you get the argon ionized, and then you'd get the particles, the vaporized particles from the electrodes. Again, that's an opinion, and I need your help refining that idea.
Huh? Can I now inject laser energy into the process that aids the process of now aiding to knock off the electrons? In other words, if I had an atomic structure this way, then the electrons would go from that orbit to K, L, M, and N orbits, and then eventually be ejected off by the voltage. Can I not do that?
Yeah.
What proves that out? How about an argon laser? If it does it? All right, so therefore...
So he's talking about lasers again, an argon laser. But, he's talking about the knocking off electrons with light, basically.
Point in the hydrogen gas gun technology. By the way, the hydrogen gas gun technology can be reduced down to the size of a spark plug or the fuel injection port of a F-18 or F-16. So you can miniaturize this thing down tremendously. Now, in this technology, as a matter of fact, when you send laser energy into this process, not only could we generate the electrolytics for all the cities in New Zealand, but I can reduce it down to the size of an IC chip and replace the battery in electronics. Isn't that phenomenal?
Now he talks about creating something as small as an IC chip into a battery. There's a thing, actually I'll just show it to you real quick. It's in this document about the newsletter 3 here. If you go down to the bottom, it gives you a description of a bunch of information. And it talks about the, where is it? Electrical polarization generator using electrical charged gas to produce electrical energy. Using electrical let me read that again. Using electrical charged gas to produce electricity. In the other video I will be showing you real quick, you can see what he's doing there, and that's a whole nother system. That's isolated from what we're doing right now.
Okay, now, get back on this a minute. if I want to be able to covalently link up with atoms that normally do not link up, then can I not just simply pluck the outer electrons of that atom and now use it as a covalent link up? So if I pluck 4 electrons from here, from the argon atom, would it not now link up with the iron ions that also have missing electrons?
Which was not possible before.
Yes, and the reason why it wasn't possible before was the invention of the VIC unit circuit. The VIC unit restrict amp flow, right? Now like a neon tube. You take a high voltage neon tube, it produced the light, it plucked off the electrons, right? And then when it was plucking off the electrons, it allowed electrons to go back in the process to stabilize it, to go ahead and pulse again at 60 cycles to release more energy, right? All right, in the VIC unit though, when you pluck the electrons, you're not allowing electrons to go back in the process. Now, so therefore, if I would now expose these two opposite gases, and I now set an inject laser energy in the process, and plucking off their electrons, if I pluck off their electrons, would they not covalently link up? Absolutely, they would have to link up. So now I have a gas lattice now, where it now can exhibit the electromagnetic field. So if I
Okay, he's talking about the VIC circuit, the hydrogen gas gun, and all those goodies. Basically what I want to show you real quick, which I gotta get the picture, is the hydrogen gas gun. Hold on. Alright guys, I got this image off of a place called globalcast.com with a K. GLOBALKAST. The site's kind of sluggish here and there, you just gotta be patient. Basically here is the hydrogen ionizer, or the ionizer gas gun is what it would be. You can see here there's 2 coils here, one up here and maybe one above that, and then there are LEDs with resistors on them all the way down through here, shining into that tube that supposedly has a piece of iron in the middle of it, which is polarized electrically, and the outside is polarized electrically, and then the LEDs, or laser energy, goes into the gas to make this process happen. There's another one here, which supposedly this one is the gas processor. The other one was called the ionizer. So I think they're the same thing, except one's nicer and newer. This is the older one. All right, let's keep going.
I would put the gas lattice down inside.
You're saying the gas lattice is argon and iron?
No, argon and iron ions, or nickel or cobalt, or any combination thereof. Okay, this is only one example.
Where do you get the ions from?
Well, if
He just asked, where do you get the iron ions from? Okay, so listen to this response.
if you have iron, can you not decompose an iron block into iron ions, and then made up of atomic structure of atoms?
Once you knock the electrons off, that's the whole thing, isn't it?
Right.
So he talks about decomposing the iron, which you can do that with an electrical arc. You can vaporize the material.
He was artificially knocking it off. As a result of this, hundreds of thousands of millions of new chemical compounds will come about. The prior art in chemistry is, if you had atom A here, and say, well, I need atom B down here, they may have had to put a whole string of other atoms to come down here to atom X, right? And the reason why they did that was because of the covalent link-up of the atoms, right? All right? Why can I not bypass the step and knock off the electrons here, and knock off the electrons here, and control it to such an extent that they have a match?
So you can get like quarter tones in the atomic structure instead of having a harmonic Pythagorean structure. You can vary that along in great further shapes.
Right, absolutely. You see that? Am I defining law of physics?
It's like artificially produced isotopes.
Right. Or artificially simply well, isotopes, if you want to talk about isotopes, you're talking about putting more 2 or 3 electrons into the orbit and everything. What we're doing is plucking the electrons out. All right, we're plucking it out. I'm injecting laser energy in the process to simply aid the process. In other words, here's the atom, and I'm now injecting the laser energy.
What sort of laser energy?
And,
helium, neon, or argon, or
doesn't matter.
Doesn't matter. Anything.
On certain atoms, it will take a different frequency of laser energy, but you simply tune in on the laser frequency of absorption, and so it does it. So basically, a photon light source works very well on it. If here are your energy orbits.
It says a photonic light source okay, which means LED, infrared, whatever frequency we need to do that. So that's his quote laser energy. It's just photons basically, which is light.
And again, you're bouncing like K, L, M, and N. So if you subject this, you're knocking off the electrons. You're subjecting to a tremendous high pulse voltage. I'm now plucking the electrons. I still have the laser energy here to keep it from going back to stable state. If I intermix those chemicals in the hydrogen fraction technology, they will covalently link up.
What sort of voltage do you need? Is it 15,000, 50,000?
Doesn't matter. Very little. How much? See, in kilos.
The high voltage plucking device.
Yeah. It doesn't. It can go from 2,000 volts to 10,000 volts, or take it to 20,000 volts up to 90,000 volts. It depends on what type of application that you want. The key was that we could produce hundreds of thousands and millions of cubic feet of magnetized gas in the garage.
Okay, in a garage with parts you can purchase. This is where it's important to remember that you got to try to stick with the basics, even though this is pretty heavy-duty stuff. That was one of Stan's deals: was keep it simple, stupid. It's KISS method. That way, it's economically able to comply with people and manufacturing aspects.
By using the hydrogen fraction technology, or hydrogen gun technology, to give us this ability.
Hydrogen gun technology, which was that picture I just showed you. That one right there. That's the hydrogen gas gun. So if you got this high voltage field here, pulse field, and LED array, this is something that we need to research, and other people have done it, researched about it. But that's a very, very important piece of this whole entire contraption device.
So now we're linking, unlike atoms that heretofore you could not link up naturally. We're artificially linking them up by plucking out their electrons. So when you expose the gas to an external magnetic field, then what happens is the magnetic field of this iron ion now starts to link up, and you produce an electromagnetic flux line.
Okay, you said an external magnetic field. Here's my question. If you took a north magnet here and a south magnet here, and you created this structure with these atoms, and then you actually had a coil that to accelerate this gas lattice, but you had it the other direction because you had a north here and a south here, what would happen to the gas? Would it turn? Would these atoms all get all messed up, or do they just always stay in that structure? That's something to think about.
Like so.
Which is opposite of the whole lot.
Yes, right, all the way around the tube, all the way around the non-magnetic tube. Now the reason why I'm using argon in this case is that there's some characteristics to argon. The characteristics being that the argon is like a lubricator. Second thing is that it's an anti-static device. It doesn't like to transmit electrical energy in it. And
It talks about anti-static, which, no explosions, the hydrogen and oxygen, if it causes an electrostatic inside that tube, it's going to blow up.
it also has the ability that's a magnetic shunt. It doesn't like to be magnetized. And as a result of that, then when you expose it, you're now creating this electromagnetic field. Isn't that amazing? So not only are you're linking up the gas lattice by covalent link up, I'm also now linking it up by the electromagnetic link up from one atom structure to another to produce the magnetic flux line.
Okay, so there's a lot to this device, and this is where your help's going to come in, for sure. So I got to create the gas, I got to vaporize the material, then I have to subject it to combine to each other covalently through photosynthesis and high voltage pulse field. Then I got to subject that to a magnetic field to align the structure properly. Then I can get my device to work. So there's a lot to think about, and a lot of information out there that I will need help with. So think about it.
So it's quite obvious now that if I would now take this, then I would expose it to the electromagnetic field moving through the pickup coil, would I not generate electrical energy?
By the way, Stan, you'll be making superconductors totally obsolete, won't you?
Yes.
He just said you will make superconductors to the obsolete. Now again, if this was a copper pipe, and these flux lines right here would be rolling on the inside of this copper pipe, they'd be rolling on the outside of this copper pipe as well. And that might be a key to this whole contraption. It very well might be.
Yes. Yes. The superconductor is basically trying to transmit electrical power without, least resistance, obviously. Okay, so that's the basic principle of why the EPG system works. Any questions?
I'm still confused about the iron ions.
Okay, he just said I'm still confused about the iron ions. He's going to explain how to do that, but he doesn't want to tell you. Listen.
How you manufacture them.
Well, if you go back many years ago, 20, 30, 40 years ago, or in the 40s, 30s and the 40s, they were using ion generators to generate ions from many different metals, even including.
So an ion generator, which could be an electrical arc or a corona field type of situation. So there again, something that you can do in your garage. High voltage electricity and an arc with some material.
Iron and cobalt and nickel. So.
Oh, you mean like an ion generator, a negative ion generator?
Sure. And you take your metals and you decompose it into the atomic structure. There's a lot of ways of doing it, but there's too many hours to describe the apparatuses.
He just said there's many ways of doing it, but it would take too many hours to describe the apparatus, which is kind of funny to me. I just think that's funny.
What makes it a magnetic gas? Why would it be magnetic?
Well, because I'm using atoms that all of their electrons spin in the same direction. So if you have an atom that all of its electrons spins in the same direction, it will exhibit an electromagnetic field equivalent to the number of electrons that are spinning under the electromagnetic theory of magnetism, that whenever an electric charged particle passes through an electrostatic field, its byproduct is electromagnetic energy.
But iron by itself is not permanently magnetized, as steel is, but iron wouldn't be.
Yeah.
So why is iron not steel? And why would that not be the same thing as normal iron?
Well, say that again now.
Well, iron, soft iron, is not
Right.
magnetic in itself, is it? Not
Yeah.
permanently magnetized.
True.
But steel is.
Yeah.
So why is that? You've got iron there. Why is it not? Why would
Well, the reason why that would, I said, now I'm giving you an example. And I said any combination thereof.
Okay, he's using it as an example, but any combination thereof, which would be hydrogen, oxygen, and what? Maybe nitrogen. I don't know. It's a good question.
You can take any combination of structures to do it. Now, when you talk about creating the electromagnetic fields and you're coming up with the combinations, you can take the combinations and mix it and expose it in the same process. The reason for that strictly is why it's holding the magnetic field is because it's allowing the electromagnetic spin to not pair together. All right. So in this particular case, the argon atoms are all pairing together and they're spinning in opposite direction. But it will stabilize to allow these electrons to spin in the same direction. But you can take any combination of any of the ion structures and put them together to create and enhance the electromagnetic field.
You could use neodymium ion boron, for example,
Sure.
which is a very...
He talks about neodymium ion boron. Neodymium magnets is another thing that would be interesting to try, although I do not know the results.
very strong magnet.
Right.
Material.
Exactly the same thing.
And that's permanent.
Right.
It remains permanent. You get permanent.
Right. Right. You can use all the state of the art, what they're using today, to enhance and stabilize that magnetic field. The real point being is that once you do this, you're not going to inject the laser energy into amplify that electromagnetic field. So you're not restricted to just one. I'm giving this as an example of the approach. If I went to a more complicated, it may be a little bit more harder to understand. Okay, so that's the basis of the EPG system technology. Now we also have some advanced technology which we're not bringing out at the present time, and that's all.
Alright guys, so there you go. That's that whole piece of information. Hope you can make it through it with me talking. Alright, let's do something else. Alright, so here's my take on that real quick. What could be permanently polarized magnetic material coming into this hydrogen and oxygen and superimposing on it? I'm going to throw something at you that I thought about for a while, and I actually talked to Craig a little bit, and the answer would be carbon. Okay, if I were to vaporize a carbon rod, welding rod, which is what I plan on doing, and it would superimpose onto the hydrogen and oxygen, but you have to run it probably through the gas processor to ionize it. I don't know. This is where your help will come in very handy because my physics level is not the best. Although my skills of building and making something function is awesome, in my opinion. Not to brag at all, but I feel pretty confident in my abilities. So, yeah, carbon rods, coal, even would even be something that you could use. Coal is even pure, a purer form of carbon, I believe. I'm reading up on that information now. So, yeah. Alright guys, I'm going to show you this picture again. I'm going to kind of just show you a few things about it and your thoughts on this. The image will be posted in the description like everything else. So take a good look at it. Here's the picture. Again, somebody found this on the forums. I don't remember who it was, my apologies. But thank you very much for sending this to me, because this is pretty extraordinary. Now, you're going to ask me, how do I know who built this? I'm like 95% sure Stan built it. There's a couple reasons of why. First of all, I need to open that in a different window. First of all, here's another one. Yeah, that's not the best picture. Let's go with this one. Okay, look here. Transformer right here. Alright, power strip right here. You see the nameplate right there? Nameplate's a giveaway. And then on some of these you can see there's really nice feet on them, and they're on a plexiglass sheet. Okay. And in this picture, poor quality. Let's try maybe this one. Yeah, we'll go back to the other one. You can see here these coils, right? They're wrapped around like separate bobbins with white tape. Okay. All of these things combined with a few other things that I've discovered leads me to believe that this is his work for sure. There's the nameplate. It's hard to see. On a nice plexiglass thing with the transformer and the controls. Okay, and then the feet, and then there's a control circuit board in here, just like I showed you. Okay, with the coils wrapped properly. Now here's the other giveaway for me. This is when I decided to pretty much assume that this was his work. Here you can see a 9-pin or 15-pin serial cable connector, okay? And up here you see the same thing. You see the serial pin connectors. Hard to see on my screen, but you look it up for yourself. That is what Stanley did in his work, as well as the nameplate in the bottom. This whole apparatus it's his work. You can just tell. Now, if it's not his work, that's fine. My apologies, but it sure does look like it, or it's a replication of his work from somebody who knew he was working on that. That's very possible as well. But in my opinion, this was Stanley's work. Especially since that nameplate's on there. Nobody's going to spend the extra money to put a nameplate on there if they weren't presenting it. Alright, so if these coils were fired in a sequence, which would be pulling gas through here, polarized gas through this device, it spirals like this, goes down a layer, spirals down a layer, down a layer, down a layer, and down a layer. Now in the patents, the very first one, I showed you pictures of the devices. And you know, they're all different shapes and sizes, and I matched it up to the other ones. Now I'm going to show you another one right here. Check that out. Now I could be totally wrong. This would be like a 3-phase type generator with the coils in the middle. Look at there. That's what you got. Alright. Now I know this is just a drawing, but if you really look at it, I mean, I can't deny the fact that that's pretty darn similar. Okay, so you know that he probably built all these devices if they're in these patents, because a lot of the pictures I've seen match up with the patents quite nicely. Okay, so anyway, that's my opinion on this picture, and you guys need to look at it for yourself. You can see their output coils here. There's also these circuit boards up here on the top, right here, with look like connectors. I'm not sure what those are. There's a set here, here, and here. It's almost like there's a little coil in here. It's a little accelerator coil or a pickup coil, or I really don't know. I need all of your opinions on this, and post it in the comments. Like I said, I didn't reply to a lot of people, but believe me, I read it. It's just been, as you can tell, I've been extremely busy researching this stuff. So that's all I'm going to say about that. Let's move on. Alright everyone, so I'm done talking about patents and information. Now I'm going to show you some real stuff I've been working on. Everybody's seen this from the last video, as well as the rustic spiral cell, which I have not encapsulated yet because I've been working on this part. This is, I believe, 3/8 airline, polypropylene airline, with some valves on the end. Now, y'all are going to like this. I decided to go ahead and build a little bit of a bigger unit because I wanted to make sure that this was going to work. Go big, right? Whatever. Here it is. I was lucky enough to have somebody donate a little bit of money to buy the piping and fittings for this. I have wrapped on here, this is PEX. If I can find, there you can see what it is, Durapex. There's the information on it. Alright, and I'm going to mount this on a board. But instead of coming off of 90s, okay, instead of doing 90s and coming into the center, and this is about, actually this is 18 inches round. You can see I'll hold it in my hands like Stan was doing. It's about the right size. Instead of making 90s, I thought the gas would flow a lot better if I just made this nice outer loop, and it's a single pipe. These are 3 tall here. Now I can put my input coils along here. I may need to kind of bend this and straighten it, but that's where my input coils are going to go. And I've got 2 valves on the ends here into 1/2-inch PEX. This is 3/4 PEX. Pretty big stuff. In those other pictures, it looks like it may be 1/2 inch, but I went ahead and got this because I bought this prior to doing extra research there. But I want to tell you guys something, and this is very important to me to work on this type of stuff for everybody. Share this information with everybody. I can't do anything by myself. I really can't. I gotta have help from everyone. Now, if you know me from my other prior videos, you know that I recycle everything. Everything I built is recycled. All the wire you see on that device right there is recycled out of electric motors. Here's a spool I got out of an electric motor. I had to take it apart. It took about 8 hours to get it all apart and unwound. Okay, and this is the device I actually built to straighten this wire. I'll show you the front side. Run the wires through these guides here, and they go into these pulleys, which straighten the wire. Then they go across here, which cleans the wire and straightens the wire and goes through and back out this other side. And then I can roll it on another roll. Now that's what I've been doing this whole time. And so that's what I've been doing the whole time, and I wanted to show you something real quick. This is my recycled wire. Every bit of this copper wire has been recycled. I've spent countless hours recycling this stuff. Look how long it'll take to untangle this stuff. Okay, and that's what I've been doing to get wire. All of my very interesting coils and such are in here. I will be testing all these geometries and trying to find out, what coils work best for pickup and drive. And I'll be sharing that information as well. It's my big Rodin, my Alb Taurus. It's half done back here. Okay, so that's what I'm doing. You can see here I got an electric motor I've been taking apart, and it's so time consuming. There's one that's stripped off already. And it's so time consuming. And so what I'm going to ask is I don't like doing this, but I'm going to go ahead and do it anyway, so those of you who don't like this, my apologies, but I'll throw this out there. I'm going to make a document, and I'm going to put a link to it, and the document's going to have stuff that I'll be needing to make this work. I haven't really spent any money on any of this stuff. Everything I do, I build from scratch. Case in point, I needed a magnetic pole tester. Built my own. Here it is. See, it's got a strength on it even, and I can plug it into my meter and tell me what that is. Okay. For Christmas, I did ask for an oscilloscope, and I was able to purchase an oscilloscope, a PC scope. I was very blessed with that. Also, some of you have watched me. I built this entire power supply because I had resources, but no money. And this whole entire thing, 4-channel, basically, 4-channel power supply. Alright, I can get 40 amps out of that sucker. And I built it for pretty much nothing. So what I'm going to ask you, I'm going to make this document up, and I'm going to put basically things I need. And I'm going to put a donation link on there for PayPal. It'll be rwg42985 at AOL.com. rwg42985 at AOL.com. That's also my email. That's also going to be a PayPal set up solely for the purpose of research and development. And anything you guys give to me, I'll give back in informational and research and development. I'm going to show everything I do. It's who I am. It's what I like doing. Unfortunately, right now I just don't have any extra money to buy anything. Salvaging takes hours. And I'm going to have to purchase some UV and infrared LEDs for the gas processor. I need some 30 gauge wire. I'll probably have to build the VIC circuit, and I have a lot of information on that as far as what size wire. It's all 30 gauge supposedly, and I can put that information in the description as well. But you know, this stuff's just it's for all of us. It's to help us all, and that's the goal behind this whole project. So I'm opening up a donation spot, and I'm also making a document of anything I have. Now, if you don't have any money, I don't either, so I'm with you. But let's say you had a roll of wire somewhere that you're not going to use that you can send to me. I will, in that document, put an address where you can send that to, and all that will be going towards the research and development of this project and other projects as well. So I just want to thank everybody for all the income, all the information, and what a great feedback from this device. I'm blessed, you guys and girls. Thank you. Now, what I want you to do right now is go copy all the information from this description and in the video, and mass email it to everybody in your Google groups, Yahoo groups, whatever groups you're in, and in all your address book you have. Just email it out, no matter who. Mom, Dad. I emailed it to my mom. She's like, "What is this? I don't even know what this is." I said, "Just send it on." You know, that's the way word gets around. All right, this is Russ. If you have any questions, comments, concerns, email rwg42985 at AOL.com. If you're watching this video on another channel, my YouTube is rwg42985. Alright? I'm done. Ready to go do something. Ready to go put some more wraps on this. Real quick, I'll explain what I'm going to do with this. This is actually copper wire, 18 gauge. This is aluminum wire, 18 gauge. Again, all recycled material. And what I'm going to do is wrap aluminum and copper, and then I'm also going to wrap thin wire, aluminum and copper, and then I'm going to double layer this with thin wire, and I'm going to cover this whole entire apparatus with wire, and I'll even be doing small sections. If I can come up with the wire, because I don't have enough, I'll be doing small sections like you see in the videos, but I just wanted to wrap it like this because I believe it'll function pretty close to the same. The next would be building one of these out of copper. And I really don't know if I'll be unwinding all this wire to recycle it to use it on the other one. So I'm just limited of resources, and I just ask if anybody's willing to help. Hey, go for it. If not, I'm in the same boat as you are. So everything's going to research and development. Alright, this is Russ. Y'all have a nice day. See ya.